Now, a Red Hat OpenShift cluster, which is highly available, so 3 master nodes and 3 worker nodes. We will use the OpenShift console in order to interact with the OpenShift cluster, and we will use something called the Platform Navigator, which is the user interface for Cloud Path for integration. Cloud Path for integration is deployed on top of OpenShift, and it includes products such as ACE, MQ, Aspera Data Power, and event streams. The Cloud Path for integration deployment of ACE begins with the ACE dashboard, which allows us to deploy bar files, which can be used to deploy ACE. What we'll also be deploying is a Horizontal Pod Autoscaler. So the purpose of this demo is to show how the Horizontal Pod Autoscaler can be defined to state what limits need to be met in order to automatically scale horizontally the ACE pods. So that Horizontal Pod Autoscaler will monitor the ACE pod or pods, and when they reach the CPU utilization that we define in the Horizontal Pod Autoscaler, it will increase the number of pods. So the way that we'll do that is by using a Postman request into the deployed ACE application, and when we force it to reach a certain CPU utilization, we'll be able to see the Horizontal Pod Autoscaler monitor that pod and as such scale it up. When we stop sending traffic via Postman, we will see that the second pod that is scaled up comes back down as the utilization of the pods is decreased. In this demo, we'll be using an ACE application developed in the ACE toolkit. So we have a REST API, which is called blocking service, as shown up here. And we will be calling a path called block, and we will be doing a post call. So the purpose of the app is that it will loop, and once completed it will send out a simple message to say that it's completed. The loop within here is to increase the utilization, which will be able to show or demonstrate how the CPU utilization increases, and then the Horizontal Pod Autoscaler will see that utilization increase, and as such will start to scale. In this project we have the ACE application as shown a little while earlier, so the blocking app application. We also have 3 distinct YAMLs. So the first is for the ACE dashboard deployment. So this is the ACE dashboard operator, which will tell OpenShift what to build and what that should look like. So this will use a dashboard operator, and we'll call it ACE dashboard, and we'll deploy it into the namespace Cloud Path for integration, or CP4I. This defines all of the different parts of the ACE dashboard that we'll use. So for example, the storage will use a persistent claim and a rook ceph fs, or file storage, that we have deployed as part of the OpenShift demo environment. We can see that we have the license accepted, the license that we'll use, and its usage. But we also have some information about the pod, size that we're going to deploy. We also have the actual ACE integration server deployment. So what this includes is the name of the application that we'll be deploying. So that we're going to call that scale app, and that's the name that will be used on the pod, which we'll show once it's deployed. And that will also be deployed into the namespace CP4I. That needs to be deployed in the same namespace as the ACE dashboard. And we can see that we have here the bar URL. So when the ACE dashboard is deployed, we will be able to go onto the UI and upload the bar file into that view. And from there, we'll get a display bar URL link, which will show us what URL we can find the bar file in. That's what we'll insert into here. And when we deploy this, it will find that bar file and deploy an integration server using that bar file. We also have the horizontal ACE scale. So this is a Horizontal Pod Autoscaler deployment that will live on the OpenShift cluster. And the name of this is Autoscale Example for this demo, also deployed into Cloud Path for integration. And what we're telling it here is that the target for scaling should be a kind integration server, which relates to the A-scale deployment kind integration server. And we've given it the name of the application that it needs to watch in order to scale up or down. So in this case, it's the scale app. So this name here matches the name of the integration server. And we can see the number of replicas that we'll allow. So we can go minimum 1, maximum 10, and the target CPU utilization percentage is 80. So that's the metric that it will be watching, and it will say once that pod gets to 80%, it will scale up to a maximum of 10. And when that CPU utilization goes below that rate, it will slowly reduce the number of replicas back down to a minimum of 1. So we're now in the OpenShift Container Platform user interface, or the console, and what we're going to do is look at what is deployed. So we have an overview here of the cluster, so that gives us the status of the cluster, so things like the cluster, control plane, and the operators. So there's one pending operator installation happening at the moment, or update. What we can also see is the cluster utilization, so things like CPU, memory, file system, and the number of pods. So you could see that increase as we horizontally scale. What we'll be using as part of this demo is the workloads and the pods, and we'll be able to do a search in our project or namespace. So the Cloud Platform Integration namespace is what we'll be using, and we'll be able to search on Scale App. So nothing's deployed at the moment, but when it is, we'll be able to see it in here, and we'll be able to see the increase in pods. What we'll also be using is the Platform Navigator, which is a Cloud Platform Integration user interface. What we'll be able to do is use the Administration Integration Capabilities section to show the ACE dashboard in once it's deployed. We'll be able to do configuration deployments such as bar files. We have now completed a brief overview of what we're going to be deploying, why we're deploying it. We've had a look at the ACE application, the YAML files that describe what we're deploying, and how OpenShift will look at those YAML files in order to create what it needs to. We had a quick look at the OpenShift cluster and the Platform Navigator, and we're now going to use the command line to deploy the ACE dashboard and the Horizontal Pod Autoscaler in preparation for the ACE deployment. So in order to get onto the command line, you would normally run an OC login command. So you can find that by going into kubadmin and click the copy login command. So even if you're not kubadmin, if you're just a regular user, you can go onto copy login command, you follow that link, it display a token, and you can use that to log on to your local terminal and log into the OpenShift command line interface. So if I run OC, I can see that we have an OpenShift client here. So we're going to use the YAMLs that we created earlier. So I'm currently in the folder which has the ACE dashboard deployment YAML. And once we've defined the YAML in our code editor, it's simple as going OC create -f, and we can copy this in. And what we'll see is that the OpenShift cluster will take that YAML and then create the dashboard. So in a second, we'll look in the OpenShift cluster and we'll be able to see that the dashboard has started to deploy. For now, we're also going to deploy the horizontal ACE scale YAML. So we'll do the same as what we've just done, which is an OC create -f. So f means the file to point at, and the horizontal ACE scale. Now that horizontal auto scaler will exist, and it will be looking for the scale app, and until that scale app is deployed, it obviously won't do any scaling. So now that we've deployed the ACE dashboard and the Horizontal Pod Autoscaler, we can see that they've been deployed here. So if we click on the Horizontal Pod Autoscaler, we can see the autoscale example, and we can see the scale target is scale app. Min pods 1, max pods 10. And in here, you can edit the Horizontal Pod Autoscaler to reduce or increase the maximum number of pods, or the minimum number of pods if you wanted high availability. So If we go into the pods section, so workloads, pods, and make sure that we're in the project CP4I, which is where we deploy the ACE dashboard using the namespace in the YAML, we can see that we've got the ACE dashboard dash here, and we can see that it's running and that it's got 2 out of 2 pods ready, meaning that it's highly available. What we can also see is the file system usage, the CPU usage, etc. of the dashboard. So this isn't relevant really to the Horizontal Pod Autoscaler, but it does give us an insight into the ACE dashboard. If we go to the platform navigator, again you can find that by going to network, routes, cloud platform integration. What we can see here is all the CP4I routes or addresses that are published within the cloud platform integration namespace, and we can see it integration navigation PN, so platform navigator. If you were to click on that link, it will take you to the platform navigator. I've already loaded that up here, and this is the platform navigator, so you can add users, install operators, integration capabilities, and we can see here in the integrations the ACE dashboard. So we could have clicked on that, but we can also go on the left pane navigation bar menu, and we go to administration, integration capabilities. So whilst that loads, we end up here with the integration capabilities, and we can see that we have the ACE dashboard. We can see the version and that it's deployed into the namespace cloud platform integration. If we click on the ACE dashboard, then this will take us through into the ACE dashboard interface view, and we have home, which gives us an overview of the servers that are created, so there's none currently. It also gives us the dashboard itself, which allows us to create servers. There's configuration, which allows us to define things like server conf overrides. It also allows us to deploy things like CCDT into generic deployment. But the important one for this demo is the bar files section, which allows us to import a bar. So we're going to click on import bar, and then we're going to click on here, and we're going to search for the application. So I can see here that we have the My Blocking app, which is in the ACE Scaling Blocking app swagger. We'll click on that, we'll choose that for upload, and we'll import it. So we can see that that's there, that's been deployed, but it's not been deployed into an integration server yet. So what we're going to do is click on the ellipses and click display bar URL. This gives us a location within the ACE dashboard for where the bar file exists, and we can copy that to the clipboard, which we'll put into the YAML, which will allow us to deploy the YAML with the bar file that's been created for this dashboard. So that's a unique identifier, so that will change if you were to deploy this into a different Cloud Pak for integration deployment, say on a different cluster. So now that we have that bar URL, we can go into our editor. In the bar URL, we can paste our new bar URL that we've just taken from the ACE dashboard. We can save that, and as we did with the other deployments, we can simply type OC create -f, and because we've updated that ACE scale deployment YAML, we can simply paste that in here and set it off. So that's been created, and if we go to the OpenShift routes, we can see that the scale app has started to be deployed. We're going to use HTTP, so we've not secured this application just for the simplicity of this demo. But in the pods, if we were to type in scale app, we can see that that container is being created. So we only defined one replica here, so we'll only expecting to see one running pod when it comes up. We can actually click on there, and we can look at things like the events and the logs, and we'll be able to see as that starts to come up. So we can see that the scale app is deployed, it's running, and we can see that there's one ready out of one. If we click on that, we can see the existing CPU utilization, so there's no utilization currently on there. But we can see the memory usage, which is the server in the background, and we can see network in, network out. If we go into the logs, we can look at the live stream of information coming through. If we expand that, we can see this in the JSON format, which is what we defined in the YAML. What we can also do is get onto the terminal, and from within here we can look at things like the ACE server, and we'll click at run, and we can see our application is deployed into there. So that's just so that we can do things like debugging and just see whether the things that we expect to be in the server are there. So we can start to see CPU usage statistics in there now. What we'll do is just go and have another double check within the platform navigator. So if we go into the dashboard view and refresh the page, we can see that the scale app is there and it's ready, one replica, and we can see the block in service. Within here we'll be able to see various pieces of information about it, and when it's a REST API we can see the endpoint that we want to call, and we can see the post block operation within that API. We've got here blocking service v1 block, it's on port 80. We can also see when we try and call this. So I've got Postman set up here, and what we can do is do a send to that service. What we'll start to see after a short while is the CPU utilization start to increase. So if we search on the scale app, we have to wait a short while for the CPU usage to catch up. We can see the request is coming here. What we can also do is make that same request on the command line, and it won't give a full response. What it'll actually do is trigger that pod to start making some internal processing, and what that application is doing, as I showed you earlier, is just looping and trying to force up the utilization of the pod. And we can start to see some information. So network in, we can see that our calls are coming in. We should be able to soon see the impact of the utilization that we're calling upon it. So the request times out, which is what we expect, and we can start to see the CPU utilization start to catch up now. So it's a little bit out, but we can start to see that increase. And if we go into our pods, we go to the scale app, what we can see is that it's the Horizontal Pod Autoscaler has seen that there's been a limit reached of 80% utilization, and we can see that it's starting to deploy a new container, and that new container is there to start dealing with the additional load. And so we've got 2 requests going, and if I call that again, we'll actually start to see new containers start to be built. So this container is creating, that is now running, and when that's ready, we'll start to see that go to 1-to-1. Again, we can see in the logs that this is being deployed and it's got successful deployment of the application. And if we continue to hit that, we'll continue to see pods be spun up to handle the load, the increasing load that is coming onto that server. So what we've done here is continue to call the application. I've opened a new window and called it from there as well, and Postman has continued to send requests across. We can see inside the dashboard that additional replicas are available now. So we can see that there's 2 replicas available for this scale app, which shows that it is increased as the amount of processing on the system has increased too. Again, we can see the CPU utilization increasing as the requests are coming through, and that is on this pod. So this pod's the new pod that's been created specifically for this purpose as part of the scaling. And in here you can see the CPU utilization has hit its limit, so you can see that it's reached full CPU utilization. We can keep calling them, and eventually that we'd end up with additional pods. So what we're going to do now is wait for these calls to be completed. And when these calls are completed, we'll start to see a reduction in the amount of total CPU utilization, and then we'll see that this scales back down without any manual intervention. So we can see here, after all of the calls have been made from the local terminals, that we ended up with 3 pods for the scale application. We can see the CPU utilization is near the maximum for both the first initial pod, which is at 0.3, which is its limit, and the scale app number 2, which is at 2.65. Now, the requests that we made have now finished, so the processing is completing. What we'll start to see is the total number of core utilization fall back down, and what we'll expect to see then is that the additional pods that are no longer needed will start to be cleansed and be removed from the system. So as we see these reductions coming down, so 0.241, that will rapidly start decreasing, and when the Horizontal Pod Autoscaler realizes this, it will slowly reduce the number of pods. Now this is important for things like capacity planning. So what we can do is make sure that there is enough replicas available to handle our peak throughput times, but obviously what we need to be careful about is having too many replicas and too high a standard CPU limit. So if we say that the CPUs can increase to say 4 vCPU, and we have a high CPU utilization on that pod, we'll start to see that we're quickly running out of space, both on the cluster, but also that the licensing cost impact of that too, as additional cores are called over a period of time. So we can start to see now that the cores are starting to rapidly decrease. So we were at 0.3, we're now at 0.18 cores for the primary, and we can also see that on the second pod it's gone back down to 0.165. Again, we can see in here, if we refresh the page, that there are 3 replicas currently running for this application. And as we see this decrease, we'll hopefully start to see very soon that it starts to decrease the number of pods. And again, you can see the CPU utilization over time by clicking on the pod, and we can see that it ramped up for a period of time, and it's now rapidly reducing as that CPU intensive process is stopping. We can also see in the home overview things like CPU utilization over time, and we can see as our request came through. And the pod count is 356, so that should reduce down to 354 as the number of pods decreases. Back to scale app. You can see these are starting to come down to next to no core utilizations, at which point we'd expect to see the pods be removed. So we're going to be a little patient and wait for that to complete. And when that does, we'll start to see those containers be deleted. So after a few seconds, we saw that the call went right down to 0.06, and actually these are starting to terminate. So they've now reduced to the point where there's no real traffic on the system, and we've gone back down to just a single pod, and that was all automatically completed. And relatively quickly, once they reached an average CPU across the three of 0.006. And we can see in the Cloud Platform Integration view in the ACE dashboard that we are back down to a single replica. Now that's all happened automatically. It has happened within the confines of what we've described, so 0.3 CPU maximum per pod, and up to a maximum of 10 replicas. So we only got it up to 3 because there wasn't much processing happening on the system, but we could have ramped that up relatively quickly and reached the maximum. But the point of the maximum obviously is so that we don't start consuming too much CPU utilization on the system and start utilizing too much of that license that is affected by the ACE vCPU. And what's important is that the CPU, when it came back down, the Horizontal Pod Autoscaler has reduced those pods back down to a single application or a single replica. And we can easily change that Horizontal Pod Autoscaler so there's a minimum of, say, 2 in a highly available mode without too much hassle, just by going into the Horizontal Pod Autoscale and changing that to 2. So in this demo, we've shown you the ACE application that we've deployed, that is CPU intensive. We've deployed it into the ACE dashboard. We've seen how we take that bar URL from the ACE dashboard and insert it into a deployment. And we have seen, as we ramp up the amount of calls to that pod, the utilization of the CPU go up, and then the pods increase with demand, and then as that demand has decreased, so too is the number of pods. So that's it for this demo. I hope you enjoyed, and thank you for watching.